Okay, so we're going to bring together the last two sections. So the first part of section 6, and then where we digressed and went back to section 4 and did the absolute value equations. So we need to talk about graphing absolute value again. Only in this sense, we're going to do some inequalities. If we have a number that is x and it's supposed to have an absolute value greater than 3, where would that be on a number line? Numbers that are greater than 3 would be numbers like 4, 5, and 6. Or if it's an absolute value, you know you could have a negative 3 in here. And when you took the absolute value of it, it would still come out positive. So, but then it's supposed to be greater. If I have numbers that would be greater than that 3, I could throw in a negative 4, take its absolute value, I would get a 4. Throw in a negative 5, take the absolute value of it, I would get 5. That would be greater than 3. So this comes out, if I look at this statement and see how it graphs, it comes out to be a disjunction when we had talked about those compound inequalities. So as far as looking at what the solutions come out to be for an absolute value inequality, what do I get when I have this greater than symbol? Well, I end up with a union, or I end up with a disjunction, whichever way you want to say it. When I see something like this, absolute value of x is less than 3. Well, what kind of numbers are those? And where are the numbers that are less than 3 units from 0? Well, I got to think about this. What numbers can I throw in here that would, and take the absolute value of them, and they end up being 3, less than 3? Well, those would be numbers like negative 2, negative 1, 0, 1, 2. Because I could not put in a negative 4. Negative 4 itself is less than 3. But if I take its absolute value, then it becomes positive 4. That is not less than 3. However, negative 2, absolute value of it is a positive 2. That is less than 3. Positive 2, put that in for x, take its absolute value. It is less than 3. So only these numbers in between negative 3 and 3 satisfy this inequality right here. So what you see is, out of this statement, what you get as a compound inequality is a conjunction or an intersection. So that's what's happening as we're solving these inequalities, these absolute value inequalities, is we see that they are linked to the compound inequalities that we had done in the first part of section 6. So let's solve some of these. And then in the way that we're going to solve them, we're going to use that negative and positive case that we had done in solving absolute value equations. So we're going to keep this expression that's inside the absolute value bars, and we're going to keep the number. So here's our positive case. I know I sort of flipped it around. We're going to keep this positive case, keep this number. We're not going to change anything about it. We still have the same inequality. We're not going to change that either. So we'll solve it just the way it is. Here's our negative case. We're going to keep this expression. We're going to keep this number. We're going to do the opposite of it. So, of course, we'll end up having that understood 1, and we'll distribute it to this expression. So we'll see how we've solved everything. Of course, over here, everything is straightforward in solving. Here you see how we've distributed the negative 1. So negative 1 times 3x, negative 3x, negative 1 times 6, you get a negative 6. And then from there, you have just a simple equation that you're solving. Adding 6 to cancel. You got to divide by that negative 3, flips your inequality, and here's the solutions that we've got. If I graph x is less than or equal to 1, that's going to be to the left of 1. If I graph x is greater than or equal to negative 5, that's going to be to the right of negative 5. And if that happens at the same time, this is going to be my and. So they come together. So you do have your intersection. And they do need to fit in here. If you think about those numbers, they've got to work in here. So if we put in, let's say we put in a negative 6 and we check this, what would negative 6 times this 3x times 3 be? You would have a negative 18. Negative 18 plus 6, that would be a negative 12. If I take the absolute value of negative 12, I get 12. Is 12 less than or equal to 9? No, that doesn't work. How about if I put a positive 2 in there? Let's see. 2 times 3 would be 6. 6 plus 6 would be 12. I take the absolute value of that. No, doesn't work. So there's just a little check to show you that, yes, this is an intersection. It has to stop between the negative 5 and the 1. We have this intersection. Here's another example. Okay, so we have the absolute value of 2x minus 2 greater than 4. Let's see our two cases. So here we kept our expression and our number right here. So here's our positive case, here's our negative case, here's our expression and our number, but here we're going to do the opposite of it. Here's just a straightforward, you know how to solve this, solving like equations, solving like regular inequalities. Here we've had to distribute this negative. So negative 1 times 2x, negative 2x, negative 1 times minus 2 or negative 2, that gives you this positive 2. And then we have to solve. Cancel out the 2, divide by this negative 2, flips your sign. So we need to be greater than 3. We need to be less than negative 1. Greater than 3 goes out to the right of 3. Less than negative 1 goes to the left of negative 1. There's no overlap. I have a pretty graph here. I didn't have one from before in my presentation. So here's less than negative 1. Here's greater than 3. You can see this is a union. So we do know that we have an OR. And then just short and sweet, take a look at this. So we're going to know from now on, here's our clue. If we have this greater than or greater than equal to symbol, we should know we have an OR. If we have a less than or equal to or a less than symbol, we will know from now on, after we've gone through this, that's kind of our dead giveaway that we have an and, that we're going to have a conjunction. Just so you know for future reference, this is the rule for just rewriting conjunctions and disjunctions for these absolute value inequalities. If you want to, you may write it like this. It's a little bit different than the way we're solving. I like the way that the solving goes because it goes straight from the equations. But just for future reference, if you want to see this rule, you may use this rule. You don't have to. You can chuck it if you want to. All right, lastly, a couple of special cases like we had done before. Here we've got an absolute value of an expression, any expression, but in this case, x minus 5, less than negative 2. Is there any way that we can have an absolute value of anything that would be less than some negative number? Think of any of the numbers that would be less than a negative number. They would continue to be negative. Can we have an absolute value that is negative? Well, no. That's not the definition of an absolute value. Absolute value is supposed to be positive. It's a distance from 0. So then there's no way for it to continue to be less than negative. So right there, as our definition, you can't have absolute value that is negative, even equal to. So then it won't even be less than a negative number. So this is no solution, just simply by the definition of our absolute value, and it won't continue to be less than a negative number. So no solution here when you see that less than symbol. All right, here we've got an expression that is greater than a negative number. Absolute value is always going to be positive or 0. When we have an expression that's greater than a negative, well, that's always going to be true because of the definition of absolute value. It's always going to be greater than a negative because it has to be 0 or positive. So what's going to happen here when you go to solve both cases for this problem, you're going to end up overlapping. So you'll get the whole real number line. So you can do that. You can solve both cases. You can see and check that it is true. But just know anytime you have a negative number here and it's going to be greater than, it will end up that you will get a disjunction, but you'll have overlapping solutions and you'll get the entire real number line. So that's 2 special cases for you.